So looking at this page, which one of the shapes do you think do not belong with the other ones? Aiden, what are you thinking?
This one, because this one's much bigger than the other ones.
Oh, what shape is that one up in the top?
A square. A square.
How do you know, Aiden, that it's a square?
Because squares have 4 sides and diamonds are turned around squares. But this one has 4 sides.
It does.
Yeah, but that one is. But it has to be a bit wider. Now that one's bigger.
But does the fact that it's bigger make it a square?
No. Sometimes you can make squares little and rectangles bigger.
Okay, so then what makes this one a square in addition to the fact that it's also bigger? Because we could have had a smaller one. Yes?
Because one, two, three, 4. This one has 4, and this one has 4, but this doesn't belong.
Oh, no, hold on a second.
Wait.
One second. What? One
That
second.
one has 4
Okay. You have a different thought, and I want to hear your thought, and I want to first get this thought so we don't get confused. So the first person said that this square didn't belong. And they explained why, but I want to know what makes this a square and not a different shape. Jordan?
I think this one doesn't belong.
Oh, no. Oh, I'm going to do yours second. I want to know first the answer to this question before we move on. So what makes this one a square? Dana?
Because if you make.
Can you tell us, Dana, what makes it a square?
Because if you make another square like that, it's a rectangle.
Right, so what makes this one a square?
Because this one is like has the same size and this one doesn't. When you cut it in half, it does. Oh. It has 2 when you cut it in half. See, it has 2 squares.
Are they squares?
No, but if you make them, if you cut this little half like this in half, then it'll make like little squares.
Oh, the little one that she drew there. But if she were to look here, what did you say is true about the big square up top here that makes it a square, Dana?
Because it has the same size.
It does. All the sides are the same size. Now, can you put this one back for a second? Because now I want to hear the other ideas. Because some people thought something different. Najma, you were telling me something different first. So come on up. Which one did you think didn't belong? Okay, why do you think this one doesn't belong, Najma? What makes it different? Can someone help Najma out? She figured that that one doesn't belong, but she's not sure on why. Can someone help explain why that one might not belong in the group? Come on, have a seat so we can see it, because it's being blocked a little bit. Sarah, why doesn't it belong?
Because this is the only one that has sides in the middle.
Oh, what do you mean by sides in the middle?
This one doesn't have a side in the middle. This one doesn't have a side in the middle. This one doesn't have a side in the middle, and this does.
What makes it have those little corners there?
Because
Yes?
it's a diamond. It's a square. Because if it's the name means what it is.
What do you mean? Like what? Why does this one, as she said, have the sides? Like when she looks here at the one that says she has She said here that this has sides in the middle.
It's because she said she meant these ones, but those aren't sides in the middle. They're sides on the side.
They are on the side, but you mean what I think she's referring to these points though, which are called vertices. They're kind of in the middle where the other vertices on the other shapes are all stuck along the side.
Yeah, but this is I noticed right here. Oh. And I noticed
because they're both touching it at the same time.
And I noticed that all of these have four sides, like 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
You're right. But just sit for a second because I get what Sarah's trying to say here. I just wonder if there's another way to kind of explain it. What else could you say about this shape? Jordan, what could you say about this one?
With this one, has side like this. Yes, some point.
It does, but there's points there and there's points there. They're all called vertices. They're at all of them.
Because if you flip this one around like this,
yes,
and you flip it around like that,
yes,
on its side and same,
yes,
it makes sharp parts just like that.
Oh, so
if you flip this one around on its sharp part and this one around its sharp part, that makes the same as this one.
Oh, so but what about that one in the corner then, Jordan?
No, if you flip this one around, it doesn't make it just gets into a doesn't make a it doesn't make diamond.
Oh, so you figured out another difference on why that one might not pose. It's okay to have other things to share, but we can't all show it on top of each other.
So this one doesn't belong.
Oh, so you have a different one, Jordan, that didn't belong. That was good thinking. I didn't see that in my head. Yes, Ricardo.
Miss Singer, even though if you flip it over, it still will be a square.
It would, but then if that's true, if we flip this one the other way around,
it'll still be a diamond.
Would it?
But if you flip the rectangle up, it will make a big square. A big rectangle.
What do you mean if we flipped it up, it would make a big rectangle or a big square, Sarah?
A big rectangle.
Oh, you mean it would be like a tall one?
Yeah.
Okay, but with this one here, if we flip this square over,
It'll be a square.
What?
It'll be a square.
So it looks like a diamond this way. So that means if we tilted this one on its side, what would it make?
Diamond, and then another diamond. But then if you do this diamond, you can't make a diamond with this.
Oh, I wonder if that's true. We'll have to see because I'm gonna try it out with you in a minute.
If you flip it over on this side, it'll be like a stretchy diamond.
So we'll have to see if that's true. We're gonna try it.